Download this code from codegive.com, link in the description below. OK, let's dive into the world of Git, a cornerstone of modern software development. This will be a long and detailed explanation, covering its core concepts, usage, creation history, and code examples. What is Git? At its heart, Git is a distributed version control system, DVCS. Let's break down what that means. Version control Git tracks changes to your files, especially source code, over time. It's like having a detailed history of your project, allowing you to revert to previous states, compare changes, and understand how your project evolved. This is crucial for collaborative projects and even solo projects where you want to experiment without fear of breaking things permanently. Distributed Unlike centralized version control systems, like Subversion or CVS, Git doesn't rely on a single central server as the sole repository. Every developer has a full copy of the project history, the repository, on their local machine. This provides several benefits. Offline work You can commit changes, branch, merge, and perform many Git operations even without an internet connection. Faster performance Local operations are significantly faster because they don't require network latency. Resilience If the central server goes down, developers can still continue working with their local repositories. Also, the project history is not lost because it is duplicated across many machines. Collaboration Flexibility Developers can share their work with anyone without the need for a central server. Why was Git created? A brief history. Git was created by Linus Torvalds, the creator of Linux, in 2005. Here's the context. BitKeeper and Linux kernel development. The Linux kernel, a massive collaborative project, was using a proprietary version control system called BitKeeper. BitKeeper was free to use for open source projects, but in 2005, the relationship between the Linux development community and Bitmover, the company behind BitKeeper, broke down. The need for a replacement. Torvalds and the Linux community needed a new version control system immediately. They had very specific requirements. Speed. The kernel development process was fast-paced, with hundreds of commits per day. The new system had to be incredibly fast for branching, merging, and committing changes. Support for distributed development. The Linux kernel was developed by a globally distributed team of developers. The new system needed to support a distributed workflow efficiently. Data integrity. It had to guarantee the integrity of the project history. Corruption of data was unacceptable. Nonlinear development. The system needed to be able to branch and merge easily. Git's birth. Torvalds decided to build a new system from scratch. He designed the fundamental architecture of Git in a very short period of time, around 2 weeks. While he was the initial architect, many other developers contributed to Git's development over the years. Key design decisions. Focus on content. Git tracks the content of files, not just file names. This means that even if you rename a file, Git can still track its history. Snapshots, not differences. Git stores snapshots of the entire project at each commit, rather than recording just the differences between files. This makes certain operations, like reverting to a previous version, much faster. Cryptographic hashing. Git uses SHA-1 hashes to identify and verify every object in the repository, files, directories, commits, etc. This provides strong data integrity. Branching and merging as core concepts. Git's branching and merging capabilities are incredibly powerful and efficient, making it easy to create and manage parallel lines of development. Git concepts and workflow. 1. Repository. Git directory, the central storage location for the project's files, history, and metadata. 2. Working directory *, the actual files in your project on your computer. This is where you edit your code. 3. Staging area. Index. A staging area is an intermediate place where you collect the changes you want to include in your next commit. Think of it as a preparation area. 4. Commits *. A commit is a snapshot of the project at a specific point in time. Each commit has a unique hash, a message describing the changes, and references to its parent commits, forming a directed acyclic graph, DAG. 5. Branches *. A branch is a pointer to a specific commit. Branches allow you to work on different features or bug fixes in isolation without affecting the main code base. The main branch, often still called master or trunk, is typically the main line of development. 6. Remote repositories *. These are copies of your repository hosted on a server, example GitHub, GitLab, Bitbucket. Remote repositories are used for collaboration and backup. Basic Git commands and examples. Let's illustrate with code examples. Assume you want to create a simple hello world program in Python and use Git to track its development. 1. Initialize a Git repository ***. This creates a hidden .git directory in your hello_world directory. This .git directory is the heart of your Git repository. 2. Create a file ***. 3. Add the file to the staging area ***. This command tells Git to track the changes in hello.py and prepare it for the next commit. You can use git add to add all modified files in the current directory and its subdirectories. 4. Commit the changes ***. This creates a new commit with a descriptive message. The M flag allows you to specify the commit message directly on the command line. Good commit messages are essential for understanding the history of your project. 5. Check the repository status ***. This command shows you the current state of your working directory, staging area, and the last commit. It will tell you if there are any modified files that are not staged or committed, or if your local branch is ahead of or behind the remote branch. 6. Viewing commit history ***. This displays the commit history of the current branch. You'll see the commit hashes, author, date, and commit messages. 7. Making changes and committing again ***. 8. Branching ***. Now you are working on a separate branch. Changes you make here won't affect the main branch until you merge them. 9. Make changes on the branch ***. 10. Switch back to the main branch ***. The hello.py file in your working directory will now reflect the state of the main branch, without the feature changes. 11. Merging ***. This command integrates the changes from the feature/new feature branch into the main branch. If there are no conflicts, Git will automatically merge the changes. 12. Resolving conflicts ***. Sometimes, Git cannot automatically merge changes. This happens when the same lines in a file have been modified on different branches. Git will mark the conflicts in the file, and you'll need to manually resolve them. You'll need to edit the file to resolve the conflicts, removing the ======= and markers and choosing the desired changes. Then 13. Working with remote repositories, GitHub, GitLab, etc. Create a repository ***. Create a new repository on a platform like GitHub. Asterisk link to the remote repository asterisk. Replace your _remote _repository _URL with the URL of your GitHub repository, example git at github.com your _username / hello _world.git. Asterisk pushing changes asterisk. The U flag sets up tracking between your local main branch and the remote origin / main branch. This means you can just use git push for subsequent pushes. Asterisk cloning a repository asterisk. This downloads the entire repository, including its history, to your computer. Asterisk pulling changes asterisk. This downloads changes from the remote repository and merges them into your local branch. Common Git commands summary. Command description. Git init initializes a new Git repository. Git clone clones a remote repository to your local machine. Git add adds changes to the staging area. Git commit creates a new commit with the staged changes. Git status shows the status of the working directory and staging area. Git log displays the commit history. Git branch creates, lists, or deletes branches. Git checkout switches between branches. Git merge merges changes from one branch into another. Git remote add adds a remote repository. Git push uploads local commits to a remote repository. Git pull downloads changes from a remote repository and merges them locally. Git fetch downloads objects and refs from another repository. Git reset resets the staging area or working directory to a specific state. Git revert creates a new commit that undoes the changes of a previous commit. Git diff shows the differences between commits, branches, etc. Git workflow best practices. Asterisk commit frequently asterisk make small, logical commits with clear messages. Asterisk branch for features asterisk create a new branch for each new feature or bug fix. Asterisk pull regularly asterisk before starting work, pull the latest changes from the remote repository to avoid conflicts. Asterisk use meaningful branch names asterisk name your branches descriptively, example feature / add user authentication, bug fix / login error. Asterisk write good commit messages asterisk explain why you made the changes, not just what you changed. Use a consistent format, example fix, corrected login form validation. Asterisk code review asterisk have your code reviewed by other developers before merging. This helps catch errors and improve code quality. Asterisk use git ignore asterisk create a .gitinary file to prevent unnecessary files, example compiled object files, IDE settings, from being tracked. Git internals, a deeper look. While you don't need to understand the inner workings of Git to use it effectively, a basic understanding can be helpful. Asterisk objects asterisk Git stores data as objects in the .git / objects directory. There are 4 main types of objects. Asterisk blobs asterisk represent the content of files. Asterisk trees asterisk represent directories and their contents, file names and pointers to blobs or other trees. Asterisk commits asterisk represent snapshots of the repository. They contain metadata, author, date, message, and a pointer to a root tree object. Asterisk tags asterisk references to specific commits, often used to mark releases. Asterisk hashes asterisk each object is identified by a SHA-1 hash of its content. This hash is used as the object's file name in the .git / objects directory. Asterisk references, refs these are pointers to commits. Branch names, example main, feature / new feature, are just refs that point to the latest commit on that branch. The head ref points to the currently checked out branch or commit. Asterisk pack files asterisk Git periodically packs multiple objects into a single file, a pack file, to save space and improve performance. Why Git is so popular? Asterisk flexibility. Asterisk Git supports a wide variety of workflows, from centralized to highly distributed. Asterisk speed. Asterisk Git is very fast, especially for local operations. Asterisk branching and merging. Asterisk Git's branching and merging capabilities are unmatched. Asterisk data integrity. Asterisk Git's use of SHA-1 hashes ensures the integrity of the project history. Asterisk open source. Asterisk Git is open source and freely available. Asterisk large ecosystem. Asterisk there's a huge ecosystem of tools and services built around Git, example GitHub, GitLab, Bitbucket, GitKraken. Advanced Git topics, beyond the basics. Asterisk rebusing. Asterisk an alternative to merging that creates a cleaner commit history. Asterisk stashing. Asterisk temporarily save changes that you don't want to commit yet. Asterisk cherry picking. Asterisk apply a specific commit from one branch to another. Asterisk submodules and subtrees. Asterisk manage dependencies on other Git repositories. Asterisk Git hooks. Asterisk scripts that run automatically when certain Git events occur, example pre-commit, post-receive. Asterisk Git workflows. Asterisk understanding different Git workflows, example Git flow, GitHub flow, GitLab flow, and choosing the right one for your team. Conclusion: Git is an essential tool for modern software development. It provides powerful version control capabilities that enable collaboration, experimentation, and efficient management of code bases. While the initial learning curve can be a bit steep, mastering Git will significantly improve your productivity and collaboration skills. Start with the basic commands and gradually explore more advanced features as you become more comfortable. Practice, experiment, and don't be afraid to make mistakes. You can always revert them. Good luck, and happy coding!